All right, so let's take a look at section 9.2. So yesterday we started looking at parametric equations, okay, which is a different way to graph. Today we're going to look at a third way, which is called polar. Okay. Polar is completely different than what we learned yesterday, which was parametric, or even than functions. Okay. With parametric and functions, you still have an x and a y axis, okay, and you would still graph parametric equations on the same kind of paper as functions, okay, like y equals mx plus b stuff. Well, polar is a little different. Okay, polar uses a whole different kind of graph paper, okay, which looks like that. So it's like graph paper, but instead of being rectangular grids or square grids, it's circular. All right? So now we're using a totally different kind of graph paper. For today, we're not going to do any kind of graphing on the calculator. You can. Okay, if you go to mode, there is an option for polar, and we'll learn about that tomorrow. Unfortunately, the calculator doesn't put circles on the screen. It doesn't put a polar grid in the background. So we'll do some sketching by hand when we get to that. All right, so we're going to start out just by looking at what's called the polar coordinate system. Right, and the most basic thing we can learn about this is how do you graph a point? Okay, just like going back to x and y axis. Do you go left or right? Do you go up and down? Okay, how do we graph points in polar? Is anybody familiar with polar? Done a little bit? All right, so in polar, you still have an origin. Okay, it also can be called the pole. But we don't have an x and a y axis anymore. Okay, so we're not going to use the variables x and y for anything in polar. Okay, what we do have in polar is we have r and we have theta. Does anybody have a guess what r stands for?
Radius.
Yep, it's the radius. Okay, it has to do with the distance from the pole. And theta is going to represent, Brendan?
The angle direction of the point.
Yeah, it's going to be the angle measured from, I guess you could say, where the positive x-axis would be. Okay, it's the angle from that point. Right, so when you write a point in polar, those are the two things you need to find. What's the distance of your point from the origin? And what's the angle from where we would put the positive x-axis? Right, so just like with x and y coordinates, the radius can be positive, it can be negative. The angle can be positive, it can be negative. Right, so we'll go through how we graph it. Right, if your radius is positive, okay, you start at the origin and you move right. Okay, very similar to how you graph a point on the x-axis. If it's positive, you move right. How far do you move? Well, it depends on what r is. Okay, however many units you have. Okay, r can also be a decimal, just like with regular coordinates. So if I had, for example, a radius of, radius of 2.5, okay, I would have to go in between grid lines. Okay, so for 2.5, I just go in between the second and third circle. Okay. Now, what direction do you think I'm going to move if r is negative? Yeah, we're going to move left. And we'll get to the angle in a second. Right, so if r is less than 0, if r is negative, move left that many units. Now for the angle, we don't describe it as left, right, up, or down because we're moving on a circle. What are the two directions we can move on a circle? Clockwise and counterclockwise. And the way that's going to be determined is whether or not it's positive or negative. What direction do you think we're going to go if theta is a positive angle?
Oh, counterclockwise.
Yeah, counterclockwise. All right, so if your angle is positive, you're going to go counterclockwise. If it's negative, you're going to go clockwise. And this is all from where you ended up after step 1. Okay, so step 1, you might move right 2 units, and then from that spot, clockwise or counterclockwise.
This isn't all one motion like graphing on a regular graph would be where you just go to one point, you go to 1, and then do the other one.
So
You know what I mean? So you would do step 1 first, and then do step 2 off of that.
yeah, that's how you do this. Do step 1 first, and then step 2 you do off of that. Yep. And we'll go through an example. Okay, we'll do some radians, we'll do some degrees, we'll do positives, negatives. Okay, we'll do everything. All right, so the first point I want to graph is 345 degrees.
Do you have graph paper like that?
I don't know. I don't have any polar graph paper. You can print it. If anybody wants some, I can always print some, and I can have it after class for the homework. But I don't have any polar graph paper right now. If you go to Google and you type in polar graph paper, you can just print, and they put like 6 on a sheet. So you can put like 6 on the front and then 6 on the back. I don't think you're going to have more than 12 graphing problems in the homework. All right. So we take a look at this one. Pat, what's my radius in example 1? 3. So because it's positive, I'm going to start by going 3 units. Which way?
To the right.
To the right. So we're going to go 3 units right. And then from there, I need to look at my angle. All right. Derek, what's my angle? And it's positive or negative? Positive, which means I go which direction? Counterclockwise.
Now, can we just like kind of estimate where it is? Like, the
Yeah. Yeah. So if this was a test question, that's fine. Okay, 45 degrees should be halfway between 0 and 90. If you say put it down here, I would mark that wrong. Okay, it's got to be reasonably close. Okay, so anywhere in that area. Okay, polar graph paper, they separate it for you. So I think on this paper it's by 15s. 0, 15, 30, 45, 60, 75, 90. So that makes it easier to estimate. Yeah. And that's it. Just 3, 45 degrees counterclockwise. Right? If you were just looking at the graph, there's no way to tell how you got to that point. Okay, we went right 3 and then counterclockwise. Okay, oh, there's other directions we can go to get to that point too. Okay, we could go clockwise instead. Okay, and we'll look at that after. Right, negative 275 degrees. Right, Tyler, what's my radius this time? Yep, negative 2. And because it's negative, which way do I start out going? Yeah, I'm going to go left 2 units. And now from this point, we're going to move 75 degrees. Okay, so Nick, is it 75 degrees clockwise or counterclockwise? Counterclockwise. All right, so 75 would be about, I'd say that's a pretty good estimate. Okay, if you went all the way, that would be 90. So it's a little bit before, but it's definitely not half. Okay, it's more than half. Okay, any questions on that one? Mm-hmm.
How do you know it's counterclockwise?
The way we know it's counterclockwise, if you look at your angle. If your angle is positive, it's counterclockwise. And then if your angle is negative, that's when it's clockwise. That's it. So it just depends if the angle is positive or negative. We haven't done a negative angle yet, but we will. Right now. All right, so 3, negative 60. Right, page, what direction do I start out with for my radius?
Right.
And how many units?
3.
Yep, 3. And Dalton, my angle here is,
Negative 60.
And
You
be-
can go clockwise.
so yep, I'm going to go clockwise. Okay, and try to make it look a little more than halfway. I think that looks like it's more than halfway. Okay, any questions on that? So negative 3, clockwise 60 degrees. All right, let's try this one. Negative 4, negative 3 pi over 2. So this time, negative radius and a negative angle. Okay, what might we want to do first here, if to help us out a little bit?
Put in degree.
Yeah, why don't we just change it to degrees? That's not necessary, but if you want to, you can. Okay, changing it to degrees doesn't affect the radius, just the angle. Anybody tell me what that angle is? Negative 3 pi over 2 in degrees? John?
Is it 270?
3 pi over 2 is 270. So this is
270.
positive 3 pi over 2 is 270.
Negative. So that's that, right?
Negative 270. Okay, so negative 270.
How do we find that out? Again, like,
To convert radians to degrees,
it's like, what is it?
multiply by 180
Yeah.
and divide by pi. Or if you know pi over 2 is 90, you're tripling pi over 2. If you triple 90, there's your 270 with a negative in front.
Yeah.
All right, so Cameron, I'm going to start out. Negative 4 tells me what direction?
Left 4.
Left 4. And where do I go from there? 270, which way?
Clockwise. To the 4. No, you go to the bottom line.
Yeah, the negative, it's going to be on the negative part of the y-axis. Right, so left 4 units, and then clockwise 270. Right, so let's draw out how we did that one. Well, left 4, and then around to 270. What's another way to get to that same point besides negative 4, negative 270? Yeah?
I will choose positive. Positive 90.
So what'd you say for your radius? Negative 4? Okay. And positive 90. Yeah. That's another way to get to the same point. Negative 4, start out that way. And then positive 90, you'd go that way. Right? What's another way?
4, negative 90.
Yep. So we could go right 4, negative 90. Right? And one more way. Brendan?
4, 270.
Yep. So we could go right 4, and then go around 270 that way. All right, so how many ways are there to get to each point in polar? 4. Okay, 2 choices, left and right, and you have 2 other choices, clockwise or counterclockwise. So it's 4 total choices. Going around more than once, I don't consider that a different way. Like if you go right and then do a couple revolutions before stopping, it's the same thing. Okay, so there's four basic ways to get to each point, not counting going around several times. Okay. Does that happen with XY coordinates? Like
What?
with xy coordinates? Like if I said, get to the point 1, 2, can you write it multiple ways? No. There's only one unique way to write every point that's xy coordinates. Okay? That's not true in polar. There's many ways to write it. Okay? And that's important because if I ask you for an answer on a test and it's a multiple choice question, you might have one answer, but I might have written it a different way. Okay? Generally, I like positive radius, positive angle. Okay? I try to stay away from the negative ones, but they're not wrong at all. All right, how about the point 0 pi?
So you just down to the small one.
Where would that point be?
90. Just down 90.
Right at the origin.
Yeah, it would stay right at the origin. And what's my angle?
90.
Pi is not 90. How much is pi? 180. All right, so you're staying right at the origin. Your radius is 0, but your angle is 180. Right, so when you put your pencil down, you just got to make sure you spin it in place. 180. That's all. Any questions on that? Okay, just make sure you do the spin. I'm going to check for that. All right, so any point that has 0 comma an angle, it's always at the origin. All right, let's switch it. Let's put the 0 for the angle. Okay, would that point be at the origin? How about Matt? What do you think? Would that be at the origin?
No, you're at 2.5.
2.5, which way?
To the right.
To the right. So if your angle is 0, where does your point always end up? How would you describe where it could be? Oh, Will? What do you think? If the angle is 0, your point is always going to end up.
90.
Can you be more specific than just the line?
It wouldn't move after you move it 2.5.
All right, so in this case, it ended up right there, but in general, where would it always be?
Origin.
Not at the origin. It could be at the origin if it was 0, 0.
365.
But any point that has an angle of 0 is always where? Mhm.
On the x-axis?
Yeah, x-axis, what we would consider the x-axis if that's what we call it. Mhm. Any questions on that? How about to get a point on the y-axis? What would always have to happen to get a point somewhere on the y-axis? Besides the origin. That's on both axes. Yeah?
Your degree would have to be 90.
Your angle could be 90,
Or like a form of 90.
Or 90, 180.
or it could be negative 90.
However
It couldn't be 180 though.
I want to be 270.
Yep, it could be 270. Okay, so I guess you could say any odd multiple of 90, 90, 270, things like that, 90 times 5, 540.
Why can't you be 180?
If it was 180, what's that? Regardless if you move left or right, 180 would move you halfway around. So it would never get you on the y-axis. Okay, so to be on the y-axis, your angle has to be an odd multiple of 90. I guess that's how you could say it. Right, and 3, 180. Okay, I'll just do this one. Right 3. And counterclockwise to 180. What would change if I made that a negative 180?
It would just go the other way. Well, hypothetically, we would move the opposite way.
Right,
Still be in the same place.
right. We'd have a different direction, but the point would be in exactly the same spot if you made that angle negative. Wouldn't change where it ends up. Okay. All right, so after going through those examples, one thing I want to make sure you understand is that there's more than one way to write a point in polar. Okay. All right, and the last two things we'll look at is how do we change a point in polar back to rectangular, and then how do we change rectangular to polar. Okay, we'll try both.
What's rectangular?
Well, that's what I'm going to ask now. So in polar, what are the two things that you're given for a coordinate? The radius and the angle. Good. How about when you're graphing on a rectangular grid? You're given an x and a y. Okay, so our goal right now is to convert an r and a theta into an x and a y. Okay, we're going to get it into rectangular. Right, so I've drawn a polar grid. Okay, we don't know if that's necessarily the first ring, the second ring, just some ring in that grid. Okay, and this point has a radius, which we'll call r, and the angle is measured from the positive x-axis, theta. Okay, any thoughts on what I could do here to figure out a formula for x and y? Yeah. Yeah, let's make a triangle. Okay, so draw an altitude from that green point straight down to the x-axis. Okay, and let's, bless you, just call those two sides x and y. Right, we've done this kind of thing many times. I think we might have even looked at it yesterday. How could I set up an equation for x using r and theta? Yeah, I would use cosine. And what would that be? It would be cosine of theta would equal what over what? Not y over r. What's the definition of cosine?
Is it x over r?
Adjacent over hypotenuse. So adjacent to theta is x over r. Okay. No y this time. That's going to be next. So now to get r on the other side, how would I move it? Multiply by r.
Cosine theta equals x.
Yep, so x is r. Cosine theta, I think we saw this yesterday. And then how would I write an equation for y? Yep, you could go back to this step. Sine of theta equals what?
R over
We already used x. X is adjacent. So now sine is opposite over hypotenuse. Fernando, can you help us out? So what did I just say sine was?
Opposite over hypotenuse.
Opposite over hypotenuse.
So y over r.
So yeah, opposite is y, hypotenuse is r. So that's going back to right triangle trig from probably chapter 6. Yeah. Okay, so make sure we gotta know that right triangle trig. Now I gotta get r on the other side. So multiply just like we did before. And what's y? R sine theta. Right, so basically, we almost have, you could consider these like parametric equations. Okay? We have a separate formula to find x and to find y. So this is how you convert an r and a theta into x. Take the cosine of your angle times r, that's x. Sine of your angle times r, that's your y. And that's it. So now we'll just try using that to figure out what that point would be in rectangular. Okay, Emily, what's r here?
2.
Yep, r is 2. And Jill, what's theta?
-200.
Yep, negative 200. So just fill in those two numbers into my formula. Okay, so x equals r cosine theta, y equals r sine theta. Now, if your angle is a multiple of 30 or 45, okay, the book is generally going to expect an exact answer. Okay? Exact answers, if you think back to your 30, 60, 90, 45, 45, 90 triangles, they have like square root of 2 in them, square root of 3, root 2 over 2, root 3 over 2, stuff like that. If your angle is not a multiple of 30 or 45, okay, they're just going to round it off. Okay, 200 is not a multiple of 30. It's not a multiple of 45. Okay, so we'll just round it off. Let's type it in and see what we get. Okay, make sure you're in degrees for this problem, because my angle is in degrees. 200, 2 cosine negative 200. Okay, so x is about negative 1.88. And y, type it in again, change it to sign, 0.68. And that's it. Okay. Just make sure you write it as a coordinate. X, comma, y. Any questions on that one? All right, let's try one more. This time the angle is 5 pi over 6. Okay, anybody tell me what 5 pi over 6 is in degrees?
150.
Yep. Pi over 6 is 30, if you remember that one. This is times 5. Okay, so it's 150. It's not necessary to change it to degrees, but I want you to see something. Is 150 a multiple of 45?
No.
No. Is it a multiple of 30?
Yeah.
Yes. So what that means is they're going to be expecting exact answers here. Okay, so numbers with the square root of 3 come up, square root of 2 come up. So you're going to maybe see like 0.866, 0.707, okay, things like that. Okay, so we have to remember what those come out to. So x is r cosine 150, r sine 150. If you want to leave it in radians, it's perfectly fine. Okay, I just wanted you to see it's a multiple of 30. All right, let's try x. You know what, forget the 3 for now. Let's just do cosine 150. Let's actually try 150. Negative 0.866. Does anybody remember what number 0.866 is? With a square root? Nope, it's not going to involve the square root of 2. It's going to involve square root of a different number. What's the other number that we used a lot? 3. Something with the square root of 3. But it's not the square root of 3. Square root of 3 is 1.7 something. Yep. It's the square root of 3 over 2. Okay, you can always check it. Okay, cosine of 150, it's just negative square root of 3 over 2. All right. So you have to recognize 0.866 as square root of 3 over 2. All right, so that was just this part. So 3 times negative square root 3 over 2. Just to clean that up, just write it like this. Negative 3 square root 3 over 2. Okay, that's my x as an exact answer. Okay, and the only time they're going to ask for that is if your angle is a multiple of 30. All right, sine 150. Okay, what's that one as a fraction? 1/2. Okay, so that one comes out a little nicer. And Amanda, 3 times 1/2 would give me, as a fraction, 3 over 2. Yep. And that's it. Just write your answer. X, comma, oops, y. Any question on that one? So that's it. That's all you have to do to change polar into rectangular. Okay. And then the last thing we'll do is we'll try a couple going the other way.
What if you wrote it in decimal?
If you wrote it in decimal and the direction said find the exact answer, you would lose points for that. Okay? So if you see numbers like, does anybody remember what that one is? 0.707? Any guess what square root it might have to do with?
3.
This one's not 3. Well, square root of 4 would just be 2. So it's square roots that don't have nice answers. Think back when we drew the 30, 60, 90 right triangle, unit circle trig. This side was 1.
2/3.
How about what was the height in our 30, 60, 90? Remember the height? The height was a half, okay, and the base was root 3/2. Right, so that diagram, that's important to know, okay, to figure out these angles. How about for my 45, 45, 90? In the unit circle, that was 1. And how long was each side? Well, what kind of triangle is this?
So right.
Yeah, it is right. Can we be more specific?
45, 45, 90.
It's a 45, 45, 90, which means,
The two sides are the same.
yeah, two sides are the same. It's isosceles. So we know whatever the base is, the height is the same thing. So, does anyone remember what they both are?
21. Are they both 1?
Nope. If they were 1 and 1, then your hypotenuse would be square root of 2. So they're both smaller than 1. Square root 2/2. Right? So now if I asked you for the sine of 45, just using that diagram, what's the sine of 45? What is it?
0.707.
As a decimal, yes. How about as a fraction? The square root of 2/2. Sine is opposite divided by hypotenuse. Okay, so square root 2/2, if you check it, is 0.707. All right, so any angle that's a multiple of 40 or 35, you want to make sure you know those answers. And those are the ones that come up most often, 0.866 and 0.707. Okay, at least for sines and cosines. All right, so let's look at the last thing, which is how we change from rectangular back to polar. Hey, it's pretty much the same diagram I had before. Okay, the only difference is now you're going to be given x and y, and you have to find the r and the theta. Okay, let's start with r. Any guess on how I could find r if I was given x and y?
Pythagorean theorem.
Yeah, we just use the Pythagorean theorem. X squared plus y squared equals r squared. All right, and how about to find theta? We can't use sine or cosine. Look at the two sides that we know. All right, we could use tangent, and what would that be? It would be tangent of what? tangent of theta. And anybody help them out? What would be my fraction on the other side? Opposite over adjacent, yep, which would be y over x. Now the only thing is I'd like to have theta by itself. Yep. So theta is the inverse tangent of y over x. Now that formula will work fine as long as you're in quadrants 1 and 4. If you're in 2 or 3, we have to make a small adjustment to that formula. Inverse tangent always gives you an answer between -90 and +90. So it would never give you an answer in quadrants 2 or 3. Right, so I'll show you how we adjust it if you're in those quadrants. Right. So to convert to polar, first thing you have to figure out is what quadrant you're in. Okay. The reason for that is because when you determine theta, it's going to depend on the quadrant. Okay, so just do a quick sketch, figure out what quadrant your point's in. And then we're going to find theta. If you're in quadrants 1 or 4, okay, I told you the formula you guys just gave me works fine. Inverse tangent y over x. But if you're in quadrants 2 or 3, okay, almost the same formula, but we have to add 180 to it. Right? Or if you're working in radians, add pi. Now, besides being in quadrants 1, 2, 3, or 4, where else could I end up? Yeah?
On one of the axes.
Right, I could end up on an axis. Okay? These formulas do not work correctly if you're on an axis. So if you're on an axis, you just have to memorize the angles. What's the angle if you're right? 0. How about if you go up?
90.
Left? Down?
270.
And 270. Okay, so if you're on an axis, you just have to memorize right is 0, up is 90, left is 180, down is 270. But together, that combined with the formulas covers everywhere you could be. Right, so that's how you determine theta. And then the last thing John told us earlier, how do you find r? It's just the Pythagorean theorem. Okay, r squared equals x squared plus y squared. All right, so we'll finish up just by converting this point to polar. Now, technically, if you want to find r first, you can, because finding r and finding theta are separate. You don't need one to do the other. So you want to do r first, or you want to do theta first? R? Okay, you can do r first. R squared equals, what's x?
3 squared.
3 squared, good. Plus, what's y? -5 squared. Okay, Cheryl, 3 squared gives me how much?
9.
9. -5 squared?
25.
Okay, so r is going to be the square root of 34. Okay, any questions on getting r? Right, and besides r, what's the other thing that I need? Theta. But theta depends on what quadrant I'm in. Okay. What quadrant is the point 3, -5 in? Not quadrant 2. 4. Right? 3 down 5. It doesn't have to be an exact sketch. Just figure out your quadrant. You can even do it in your head if you want. Okay. What's my formula for theta in quadrant 4?
Theta equals inverse tangent of y over x.
Inverse tangent y over x. Yep. You don't add 180 in this quadrant. Okay, so inverse tangent of -5. What was x? 3?
3.
Yep. Thank you. So my angle is -59.04. So my final answer, my radius, square root 34, angle, -59.04. And how many ways are there to write that point? 4. I'm not going to go through them all. I think the easiest way to rewrite it is to sketch it on paper and take your pencil and draw the different ways. You could probably come up with formulas in your head for doing it, but I think a sketch is the easiest. Okay, last one, 0,6. What's the angle for 0,6?
6.
6, that's something else, but it's not my angle. 90. Okay, 0,6 if you graph it. That's the point 0,6. Okay, we're on an axis, we have to memorize that angle. What's my radius? 6. Okay, anytime you're on an axis, one of the coordinates is 0, the other number is your radius. Okay, you don't need to do 0 squared plus 6 squared equals r squared. You can just count 6 units on. So this point becomes r theta. And I like the way that one's written. It's positive, positive. I wouldn't change it. Right, so tomorrow we'll look at stuff with the graphing calculator, okay, how we can graph in polar. And then we'll make a connection between parametric and polar, okay, how we can convert between those two. Any questions on that? All right, so the homework, it's on 492. It's about the same number of problems as last night. It's just they're all right in order. Just 1 to 14, all. All right, so we'll go over homework first thing tomorrow, and then we will finish 9.2.